All right. So you guys should be kind of getting used to seeing this page really, because now we're going to be doing transformations, right? But we're just doing them now to a log graph. So 1 second though, I'm just going to show you what we're applying it to. So, okay. So if we're looking at the equation, you can't see it right there, but y is equal to log base 2 of x, right? Well, that's going to be our base, like where we're starting from, right? Is that function. So here, I'll delete that one out. So this is kind of where we're starting, and then we're doing transformations to this. But unlike the other ones, it won't always be exactly the same because, well, I guess exponents are like this too, but you can change this to log base 5, right? And that'll look a little different. Do you guys kind of see, just like, here, I will write it, y is equal to 5 to the power of x. How 5 to the power of x rises more quickly than 2 to the power of x. You guys see that? Yeah, well, the same thing's gonna be true with base 5, right? But can you see that it's going to like flatten out closer and closer to like the x-axis this time? So if this was, you know, base 2, you know, it kind of goes up like this, and then base 5 is gonna hug the x-axis more, like it's right. Yeah, if that makes sense. Okay, so we're gonna be comparing it to just that basic equation there. So let's look at some of these. All right, let's figure out our translations on this guy. So first off, let's write this a little different so we can kind of see it a bit more clearly. I'm going to rewrite this as y is equal to log base 4 of x plus 4 and then minus 5. Just brought the 5 over. Okay, so what do we got going on here? We have a horizontal translation of what? Yeah, 4 left. Okay, we have a vertical translation of, yeah, 5 down. Okay, and the question is asking us to describe the effects on the domain, the range, the asymptotes, the X and Y intercepts, and the end behavior. So remember what we're doing. We're applying it to this, right? Is the idea. Oh. So vertical asymptote. So our vertical asymptote on the original would have been x is equal to, well, what would that have been just on the base function? Here, maybe I'll write down the base function we're comparing it to would be y is equal to log base 4 of just x. Log base 4 of x. Right? So that function, but I guess that'd be a 4, sorry. So what was the vertical asymptote on that one? X is equal to 0, right? So we'll say x is equal to 0. What does that become? So I'll just draw like a little arrow here showing this will end up becoming, well, a vertical asymptote of x is equal to, and then what do you guys think would happen if, yeah, go 4 to the left. So the asymptote would too, right? Everything would move over. So it's only really going to be, you guys see the pattern here too, it's only going to be things that are happening in the horizontal direction that would affect that asymptote, right? So no matter what I do in the y direction, right? If I stretch it up or if I like translate it up, is that going to have any effect on the asymptote? No, right? So it's only horizontal things I'm looking at here. So that is going to be x is equal to -4, right? Move 4 to the left. Okay, so then on that same vein here, let's figure out the domain. So the domain of the original was happening at, well, what would that be? So x would have to be greater than 0 on the original, and that's just looking at this, right? It just has to be greater than 0 on that function. And then the new domain, we'll say, so domain, x has to be greater than -4 now. Okay, the range, well, this one's easy because the range was just a member of the real numbers to begin with. And, well, even though I did translate this thing down 5, does that matter? No, because I translated it down 5. It was infinity before. If I move the whole thing down, it's still infinity to infinity, right? So we're still going to be, yeah, we're going to be negative infinity minus 4. Or minus 5, sorry. So the range would just be y is a member of the real numbers still. Okay, so now it wanted us to find, I hope you guys have enough room, find the x and y intercepts of this. So let's do our x-intercept. All right, so like when we're always finding the x-intercept, what should we do? We should make y equal to 0. So we'll just do that. We'll go back to our original equation here, and we'll just make y equal to 0 plus 5 equals log base 4 of x plus 4. Okay, so let's write this down again. So this would be the same thing as, well, 5 is equal to log base 4 of x plus 4. How do I solve for that x in there now? It's kind of trapped in the log part, right? Any ideas on how we can handle this? Maybe from last lesson? Yep. Yeah, I think we might be able to see it a bit more clearly if we convert this to exponential form, right? So again, this our base would be 4, so that's a good place to start, right? I'm going to write 4 to the power of 5. Yeah, that is the exponent, like that's what it's equal to, right? And that's equal to what the log was, so x plus 4. Okay, so that seems a lot better. So minus 4 from each side. So we've got 4 to the power of 5 minus 4 is equal to x. So that ends up being a big number, 1020. Okay, so we'll do the same little thing here, the x-intercept on the original. So x-intercept was at the point 1, 0. And now it's going to become x-intercept of 1020, 0. Are you guys okay with the original x-intercept being 1, 0 as well? Right, that's just from our function there, right? Okay, y-intercept. All right, so our y-intercept, what should be 0 in this case? X, right? So we'll do the same thing, but we'll write, so I'm going to write it as y is equal to log base 4 of, and then instead of an x, I'm going to put 0 plus 4, and then minus 5. So y is equal to log base 4 of 4 minus 5. Anyone have any idea what log base 4 of 4 is? Yeah. 1. How'd you know that?
Well, because 4, the logarithms ask 4 to the power of what gives you 4.
Right.
Anything to the power of what gives itself.
Exactly, right? So remember, when we're looking at logarithm here, right, we're saying 4, the base, to the power of what gives you 4. Okay, so we can do this one in our head. That's 1, right? 4 to the power of 1 is 4. So y is equal to 1 minus 5. So y is equal to negative 4. Okay, so the y-intercept on the original. So the y-intercept on the original, well, what would that be on the original? Just maybe looking back at this. Doesn't have one, right? Doesn't mean that it can't after we translate it, right? So originally it had none. And then the new y-intercept would be at 0, comma, negative 4. And then the last part was saying any invariant points, but we don't have any invariant points. Everything's going to shift there. So let's skip down to C, I think. B would be very similar. And I might kind of shorten it up a bit. I might just say where the vertical asymptote is instead of doing the whole like where was it and where did it go. So, all right, let's look at this one. Let's write this a bit more clearly again. So this would be the same thing as y is equal to 2 log base 3. And then what do we do with this mess? 3 minus x. Yeah, that'd be the same thing, right, as negative x plus 3. Okay, so I can write it like that, negative x plus 3. And then plus 5. Am I forgetting anything though? Yeah, C to B, right? This looks pretty good, but it's out front here. I need to actually factor it out. I need to factor that negative out because that's going to change my translation here, my horizontal translation. So let's factor out negative 1 out front here. So y is equal to 2 log base 3 of negative 1 and then x minus 3 plus 5. So now we can kind of see what's going on a bit more clearly, right? All right, so what's happening here? The 2 means that we have a vertical stretch of, I'll just say 2. And technically that would be like in the x-axis, right? But I'm just doing shorthand for now. Okay, what about the negative 1? What's that doing? Yeah, it's horizontal stretch of negative 1 or horizontal reflection. So horizontal HR, if you like, in the y-axis. Okay, what's the x minus 3 doing? It's giving us a horizontal translation of 3, or 3 right. Say positive 3. Okay, and then the 5 gives us a vertical translation of 5 up, or plus 5. All right, there's all our things. All right, so our vertical asymptote. You know what? I will do it just for the first one here. Vertical asymptote originally was at x is equal to 0. Now the vertical asymptote would be at what?
3.
Yeah. So it's going 3 to the right, right? So that's happening from this one. It's going 3. The whole thing is being shifted 3 to the right. So that's going to be at 3. All right. Now the domain. The domain of the original would be x is greater than 0. What's the domain of the new one? So we're saying x has to be greater than 3, we're saying, right? There's just one little thing we're forgetting here. We're missing.
Less than 3.
Yeah, less than 3. How'd you know it was less than 3? The reflection did it, right? So just be careful on those because, yeah, it did. The asymptote is still at 3, but you can imagine, right, if this graph was originally doing this, right? This thing has reflected. So now it moved over to 3, like that's the new one, but it reflected as well. So this thing is now, you know, going like this way. So it's got to be less than 3. It's everything to the left of 3. Okay, so the domain would be x has to be less than 3. Okay, and then the range will still just be the same, right? It's going infinity to infinity. So y is a member of the real numbers. Okay, X-Intercepts. Well, you know what? I did the last one. I'm going to pause it. I'm going to get you guys to do it. So X-Intercepts, can you guys find them? What we did here. So, all right, so here's the answer. Okay, so what we did, it was probably this step that's a little confusing. So we got everything over to one side, so negative 5 over 2. Is everyone good with that move? Yeah? Okay. And then at this point, we're just rewriting this in exponential form. So this was 3, right? 3 to the power of negative 5 over 2 gives us 3 minus x. Yeah? Okay, and then from there, I just rearranged for x to have 3 minus 3 to the power of negative 5 over 2. And at this point, that could go right in your calculator like that, right? And I get approximately 2.9, like when it rounds. Okay, so our x-intercept would just be at the point 2.9, comma 0. Okay. Y-intercept. So our Y-intercept, I'll let you guys do this one again. So if I'm looking for my Y-intercept, what's going to be 0? X. Yeah, okay. I'll let you guys try. So the new thing here would have been, or the new thing we've learned today, would have been this log base 3 of 3, right? Just knowing what that would be. You could put that in your calculator, but you're going to get 1 out of that, right? 3 to the power of 1 is equal to 3. So 2 times 1 is just 2, and then plus 5. Okay. All right, just moving on. Okay, so a reflection in the x-axis can be demonstrated 2 ways. So this one immediately probably makes sense, right? Because that's just a negative a value, which would flip it over the x-axis, right? But it can also be with a fractional base. And to see why that makes sense, let's say if we had well, like this example here with log base 5, right? So if we had actually, you know what? Here, let's sketch it first. So if I sketch this thing quickly, then y is equal to log base 5 would look something like that. So log base 5 of x. And then the inverse would look like that, right? And I'm saying that y is equal to negative log base 5 of x would be the same thing as y is equal to log base 1 over 5 of x. And to see why that makes sense, let's rewrite log base 5 of x as the inverse. Well, first off, let's write it as the exponent. So that'd be the same thing as 5 to the power of y is equal to x. So the inverse of that, right, would be 5 to the power of x is equal to y. Yeah? So that's really what we got going on there. But if we're looking at this one now with 1 over 5, so it's like we're replacing the 5 with 1 over 5. So 1 over 5 to the power of x is equal to y. Well,
Same thing as 5 to the negative x.
right. So that's the same thing as saying 5 to the power of negative x is equal to y. Sorry, I got my x's and y's mixed up. So when we did the inverse, so we should have done the inverse of this one. So this would have been 5 to the negative y is equal to x there. Sorry. And then when you're looking at this, now that we have a negative y value, it's the same thing. You're going to have like a flip over the x-axis there. But yeah, tell you the truth, you guys don't really run into this in 30-1. You would maybe like in college level, but it's not technically part of the program studies, so it's going to be a negative out front for us. Good? Okay, and then just lastly, another one that's not technically part of the program of studies for 30-1, which is kind of strange because it is part of the program of studies for 30-2, is something called natural logarithms. And what natural logarithms are is they are the inverse of e to the power of something. Have you guys ever seen this symbol? Yeah, it's actually called Euler's number. And so if I had like y is equal to e to the power of x, well, the inverse of that is called like the natural logarithm, and it's just written a different way. So that would be the same thing as, so the inverse of that would be, so natural log of x. So like that. You guys might see that come up like maybe once or twice, but like I said, technically you'd never see it on a diploma because it's not part of the 30-1 program studies. So, but college, definitely. This is probably the most common way to use logarithms.